Good morning, guys. How's it going? Hopefully well. Hope you enjoyed your break. Today we're going to talk about something called direct variation. I'm going to give you a crash course on it. Two examples should be enough for right now. So just to talk to you about it, you have already seen these problems that are solved. Direct variation are problems that are solved using the equation y equals kx, meaning any number and then an x, nothing after it. Like y equals mx plus b, but there's no plus b. So for something to vary directly, it has to fall under this formula, y equals kx, and k is called your constant of variation. It is always a number. Constant is a number. So for an example, the total cost of filling up your car with gas varies directly. It'll tell you that, varies directly. So you already know y equals kx is part of our equation. So it varies directly with the number of gallons of gasoline you are purchasing. If a gallon of gas costs $2.25, how many gallons could you purchase for $18? So, first thing, we've always taught you all this. It's always smart to make an XY chart so you know what X and Y represent. Well, it says it's gallons of gas and it's a total amount. Well, we know that Y is always our total, and X is the number of gallons. Correct? Number of gallons that you are purchasing and the total cost. So, something nice about every direct variation, you know it's a direct variation if it goes through the origin. And you're going to notice I put a little note way at the bottom of our notes today. Is you know a linear graph's a direct variation if it goes through the origin. So if I bought 0 gallons of gas, my total better be 0. It's directly related to each other. Now, if I bought 1 gallon of gas, how much would that cost me? Well, it says a gallon of gas costs $2.25. So we could continue this. I'm not going to do that. But if we bought 2, it would be $4.50, so on and so forth. And they want to know how many gallons could you purchase for $18? Yes, we could continue this all the way down till we get to $18. But we can also use this formula. What is our constant of variation? Well, how much is it per gallon? It's a number per gallon. Well, we know it's y equals $2.25 per gallon. That's your equation. It's that simple. There's a constant right there. Okay, so your constant of variation is $2.25. Now, if they want you to solve this, how many gallons could you purchase for $18? Well, gallons is what? X. You're solving for X. Y is your total. So if my total was $18, they want to know how many gallons could I buy? So you're just solving for X. I'm changing Y to 18 because that's my total. And finally, how many gallons would I be able to get? Well, I would divide both of these numbers by 2.25. And final answer, X would equal our number of gallons, right? Would equal, and I believe that is, wait for it, 8. That is it. Okay. Next part, second and last example, keeping it simple today. Hold on, paper's acting up. Okay, hopefully y'all can see that. All right, so in our next one, I don't like that it's blurry. Give me a second. There we go. All right, so in outer space, the distance of an object varies directly. So we already know that the distance varies directly with the amount of time that it travels. The amount of time that it travels. So time, there's some value. So again, varies directly. Distance varies directly with some amount. We don't know what that amount is. That's K. With time. So let's see what they tell us. Again, if you want to change this to y equals kx, you can. X and y, what do they represent? Well, y represents distance, x represents time, and they want you to find the constant of variation. They actually want you to find k. So let's see if they gave us enough information. So if an asteroid travels 3,000 miles, is that distance or is that time? Well, that's distance. So I'm going to change my d or y to 3,000 equals, I'm solving for my constant of variation. I'm solving for k. Sorry, off the screen a little bit. Again, my distance is 3,000 miles, so d or y is 3,000 equals, they want us to find the constant, find k, and they told us how many hours, and x represents time, so that would be 6. So k times 6. X now changes to 6. All right, so now, again, we're solving for k. So I know that 3,000, what's k times 6? Well, that's 6k. Final step, I can divide by 6. And k would equal, I believe that's a 5 and 2 zeros, 500. That sounds right. Okay, so my constant of variation is 500. If I wanted to write this as a formula, I could say distance equals 500t. All right. Last thing to mention is if you ever see a physical graph such as these, and they ask you, is it a direct variation or not? The easiest way to do things is if you see a physical line, just make sure it goes through the origin. Because even in this problem, if my time was 0, my distance would be 0, correct? If time was 0, how far would it travel? Nothing. So that's how you know something's a direct variation, is if it goes through the origin. It's that simple. So I wish you the best of luck on your homework. It is very similar to what you have on here, so please do your very best.